Okay, this one is a short one on molarity. So, molarity is how we use to describe the concentration of a solution. And so, a solution is just when we take a solute and dissolve it in a solvent, then whenever if they have favorable interactions, then you'll get a homogeneous solution that we call a solution. And so the classic example, salt water, salt would be the solute, the water would be the solvent, and then whenever it dissolves, you get the nice homogeneous, you can take fractions of it. So we have a bunch of different ways we talk about it, but the most common in chemistry is molarity. And the reason for it is that moles is the units that allow us to do stoichiometry and it's going to build off. You'll have limiting reagent, excess reagent, all those kinds of things. And volume is very easy to measure out. If we're going to measure out grams, you'll find sometimes like you'll want to have 12.5, and then based on the size of the clusters and maybe it'll clump and stuff like that. Once we dissolve in the solution from the glassware, it's very easy to get the volume we want, and you'll see we have specialized glassware for it. So let's look at the calculation with molarity. So the easiest one is if you're given moles of something and you're given volume in liters, then you simply divide it and you get molarity. Often the case though, we're giving grams. All right. And so what we'll need to do is that if we're given grams of it, then we'll need to take uh, grams and convert that to moles. So the same kind of stoichiometry you had before. And then in this case, it's using even a more difficult where they have like 32% solution. So they need to kind of account for that. But we'll just look at what we have to do. We have to take the grams and use dimensional analysis and get it to moles. And then we'll take the volume in milliliters and convert that to liters and get those two pieces, then moles over volume in liters, and solve for the molarity of it. Other problems, then um, so suppose you want to make a 2.5 molar HCl using 10 molar HCl. So you need to dilute it. We actually have two unknowns in this. So it depends on how much solution we want. So often it'll actually give you a volume. All right. So if you want to make 1 liter of 2.5 molar HCl, then you have a volume and a concentration, so we can find the moles. And now that we know moles, then we can come and look on this side. We have concentration, and from here we have moles. We're able to find volumes for it. All right. And so that's what it looks like. We have liters here, and we have 2.5 molar, and now we're change it to get the units to cancel. Molarity means moles per liter, and so we get moles of HCl. And then just from dimensional analysis side, we can see how we take the moles of HCl here and cancel it by using this 10 molar, all right? And it's 10 moles per liter, and 1 liter equals 1,000 milliliters, so they just did it in one step and solved for it. So that's just a simple overview of concentration and using molarity, and these pieces will come together over several labs.